Oh yeah, it just froze. Okay, we can go. So for the second episode, I have prepared. Oh my, there's a lot of bombs. Okay, let's just. Oh right, you cannot see my screen. Haha, my bad. Yeah, yeah, yeah. Go. Yeah, but maybe you can stay in the recording. I mean, I don't really mind. Okay, so you can see the script now. Okay, so let's do a trick. Right, so this is the script for the bomb, the tutorial one, and this is the script for a bomb spawner. This will spawn bomb. So let's actually see. Right, there's there's a lot of bombs already. So there's the bomb spawner in the middle, and it draws particles in, and then you can see it charging, and then it creates bombs. Right. Yeah, I especially like the spinning. So okay, so what does this do? And I think I can hear myself. Yeah, I can hear myself a little bit. Do you have headphones? Yeah, but I can hear myself when I speak, so it's not that great for the recording. Yeah, sure, you can try. I mean, if you don't fix that, it doesn't matter. I can record this later myself, but it would be great if you could fix that. Well, do you have headphones? Like, okay, well, never mind. So let's just continue. So first, let's start with the charging, right? How is it sucking the particles in? Now you can see there is field that's pointing towards the middle. Now the field is generated in the code, so we want to know how is the field generated, right? Yeah. So here it is, the craziness. But you have seen functions, right? So just for those who don't know, the code goes like this, and when it encounters a function, it goes into the function, executes the right. There is a loop, so this goes a bunch of times, and when it leaves the functions, it continues where it entered the function, right? So what we have here? Well, we save the current coordinates. Let me show you on MS Paint, and then we go over the range. So if this is the maximum range, we want to go over every single cell. So that's why there are two loops, one to go left and right, and the other one to go up and down. So if we are here, for example, then since I is going left and right, so that's like -2, for example, and y is going up and down. I mean, j is going up and down, and it is being added to the y. So here is maybe 3, and that is the j. What in this instance, right? It will go over every cell, and in this case, these two will have these values. Does that make sense? Right. So yeah. Yeah, of course. So maybe this, like, why is it like this? Is one question, and what does the rest do? And it's too confusing when it's all at once. So maybe start with something simpler. So let's do a new script. Let's do loop test, and let's just refresh our knowledge on loops. So the basic idea is write the numbers from 1 to 10, right? And for that you do actually 1 to 11, which I will explain why later. And then you do this. Oh no. And I just duplicated by accident. So this will execute this code 10 times, and it will go from 1 to 10. Now, why is 11 here? Because the I here, this will read the internal value of this loop. And this is the initial value. So when this loop is going for the first time, it has this value for the first time. So if we just do something like this, then we will see once printed in the debug stream what this does. So if I I'll just delete this for now. Oh, we actually have to we have to make a core and add this. No, whatever. Add the script to it, right? So we unpause, and we see that it prints from 1 to 10. So when this the code will loop through here several times, and the first time the internal variable will have this value, that is the initial value, and this is the maximal value. And the interesting thing is that when I is 10, it will still go inside, right? But the next time when I would be 11, it doesn't. So it stops at 11 and it doesn't go in at 11. Now, this might feel strange, but there's a very good reason for it. And the reason is list. You have seen lists? Right, so I will explain for those who didn't. A list is a data structure that can store multiple values in it. And to create an empty list, you just write create list, right? And you save it into a variable. And then the two most common things you want to do is to add values to the list and append to list is one of the easiest way. You just pass the list you want to add the value to, and then you add the value that you want to add to the list, and then you call append to list. Now we can call this several times and see what the list looks like. Alright, so this is probably what you already know, right? And here we can see the values in the list. And if we want to read the value, maybe the second value from the list, we are interested in it. Now we can see it here, of course, but let's get our hands on it here. We use get list element. Now why did I write 1 here when we want the second value? Well, because this is called an index. The elements in the list are on each element is on a different index, and this is on index 0. The index starts from 0. This is just the way it is. So the first element is at index 0, the second element is at index 1, and so on. So if we want the second element, we want to use index 1. And we get the element and we see what it is. So, right, it is the second element 5. Now this goes really well with the loop, because if we want to trace all elements, now this will trace the list, but if we want to go through each element and maybe add 1 to it and then print it out, that what we can do is get the number of the elements in the list. This will just get return 4 because there are 4 elements. And then we do this. So this will go from 0 to 4. But in reality, it will go only from 0 to 3, right? Because it will not do the for itself. But we can now easily do this, right? And as I said, we can add one to the no, not like this. It wouldn't work here, right? Because we get the element, we add one, and we print it out. So let's see what happens. Right, so we +1, +1, +1, and +1. So this is why this upper bound, you could call it, itself isn't in the loop, because you most of the time you want to use it like this, and then you would need to write this other, and that wouldn't make sense. So that's why when you want to write from 1 to 10, you actually go 11. So that's pretty much it. Now let's do one last example, and that is, let's do the small, I don't know how to say it in English, we call it násobilka, but once I write it, you will know what it is. It is the, multiplication table. So how do we do that? Well, the variable I in fact stands for the closest most loop. So that would be this one. And if we want to access the inner variable of this loop, then we use the next letter, J. And you can only nest 3 loops into each other. So we could do one more with K, right? We could do that, but no more. And if you need to nest 4 loops into one another, then you are probably doing something wrong. But let's do the multiplication table and write something like I times J is, and then multiply them. And now what we have is 1, 2, 3, 4, 5 values on top of the stack. Now how to print all of them? Well, we can just use concat, which will, we actually need to put some spaces, so it is readable. Now concat, when there are 2 values on stack, I want this one, right, 1, 2, the concat will take them and put them together, and it will put them as a string. So maybe if this is 5 times 6 is 30, it has the is and 30 on top of stack, so it will glue them together and it will say is 30. Now since there are 5 values on the stack, right, 1, 2, 3, 4, 5, we need to call this 4 times, so that every time we call this, 2 of the values will get together. So if there is 5 of them, we need to call it 4 times to all glue together, and then we print it. So let's see, and we have it like this. So maybe we don't want the first item to change so much. We want this to stay the same and this change a lot. So we want the other way around, right? We want like this. And this is what I said earlier, that I is actually this one, that changes with every iteration, and J changes only once in a while. So now you can see that this changes only one every 10 times, and the math checks out as well. So what do we want to do here? Now it's, I think, important to think about what we want to do before we do it. So all the arrows are in this area, right? You could think of this as a box. Yeah, we want to, well, the rotation is actually very simple. What is the complicated bit is the amount of the force. But let's just think, how do we even write a code that would write the coordinates of each of these cells, right? Let's start simple, and you can see at here the coordinates, and we would want to just print it every coordinate here. Well, we definitely want to use two loops nested together. But what are the indexes? Well, we would want to start at maybe minus the range. So let's say the range is 10. And we would want to end at range plus 1. Because if this is the center, then we want to go up to range to the left and the range to the right. And you can set the range, right? So this attraction zone can be bigger, it can be smaller, and the radius of the zone is called range in this script. So if the range was 10, you would do this, because you would want this to represent maybe the left and right movement from the center. So you need to go up to 10 places to the left from the center and up to 10 places to the right. But you need to put 11 here, because the 11 itself will not be used, right? So that is why it looks like this. It starts at the range and you negate that. So if the range is 10, you start at negative 10 and you end at 10. So that y is 11 here, if this would be 10, right? So that if the j, this is the variable inside this that is being counted, is equal to this, then it will still execute. But once it is equal to this, it will not execute anymore. Does that make sense? Yeah, so once we are inside here, we are at some position. So let's say we are like where this bomb is. Now, we haven't really decided if I will count the movement left and right or up or down, but it doesn't really matter, because the only difference would be in what order would the arrows be filled. Would they be filled like this or like this? Now, it doesn't matter because the value would be the same in the end, but I always try to use I for X and J for Y. So if we think about it, the I will change a lot. That means the X value will change a lot. That means it will be filling like this. Right, but that's not important. What is important is if we are here, that means the I is actually negative because we are on the left from the start. Yeah, and we add it to the mistake, to the position of the center to get this position, and I call this the target position. So next we compute the distance from the center and the target position, and we divide it by the range. So if the distance is 20 and the range is 30, we get 0.666, right? And we save it as I call it scaled distance because it is the distance scaled from 0 to 1. Now if the distance is less than 1, because we don't want to put force here, right? The distance is greater than 1, even though we compute in all this square, because computing in this would be too difficult. So we just compute in the square and then we skip these. So this is skipping the ones, the cells that are too far away. And here there's a magic formula that I will not try to explain now. Let's use this one. Because here the distance is small, but the force should be great. And here the distance is great, like it's almost 1, but the force should be low. So we need to do 1 minus the distance, and that will be the force. Nice. And now, do you know 8 and 2? What is that? Yeah, so this is a function that, yeah, so if you have a point, like we have the point somewhere here, and here is the center, and here is the target. So if you give the coordinates of the target, and you need to use the y coordinate first and then the x coordinate, by the way, and you can look this up, right? This will over this, right? So here you can probably read on it, and it will give you this angle, right? And that is what we want. We want angle, and we want to also add the offset. So let this set to 0 for now, right? So this will just add 0, so we can ignore it, and we can store the angle. Now you can also see that we are adding a pi to the angle. It's because it is measured in radians, and when we do this like this, it will measure this angle, and this angle corresponds to this direction. But if here is the target and here is the center, we want the force to be going in this direction, which is the opposite. So we add pi to the angle, and pi is exactly 180, right? So it reverses the angle from the target to the center. And then we add the offset, and that would make something like this or like this, and that will add the spinning effect. So let's add the spinning effect in, and positive will do clockwise and negative counterclockwise, I think, if I'm not mistaken. So what next? Yeah, we have the angle. Now all we have to do is set the force in the cell. Now that's simple. You just call this function, right? Again, we can see now what it does. And it just takes the coordinates and the force. Very simple. So the coordinates are the target, and the force at x is the cosine of the angle multiplied by the force. Do you know why we take the cosine of the angle? Okay, so so again, this is the angle, right, computed here. Now why do we take a cosine? Well, oh, that is terrible. Maybe like this and like this. Okay, so if we want to know the x coordinates, this one, and this is the angle. Oh, it's not really nicely drawn because the angle is actually negative in this example. So let's draw it with a positive angle because it will be easier to show, right? So we want this distance. So we have the angle here, and we know this is 1 because when we look at the fields, then the red fields have the value of 1, and as we go closer here, then the value goes to 0. Wait. Oh yeah, we just, if this is 1, we are interested in this distance. So the cosine of this angle is this distance because this is 1. And that is like the basic mathematics of the cosine. If you put an angle in a right angled triangle, it will give you the ratio of the distance next to the angle to the hypotenuse, is this called, I believe. And since this is 1, then the cosine will give you just this distance. And that is why for the x coordinate you use cosine, and then you multiply by force. So when it's far away and the force is small, you don't want to be this, you don't want this to be 1, you want it to be like smaller, like this. So this is actually the force, the length of this. And you do the same for y with sine. because again sine is the opposite side from the angle. With no, the sine of the angle is the ratio of this side to this side, and this side is the force. So you take the ratio and you multiply it by the force and you get this. And this is the y coordinate. So that's why we are using it as a y coordinate. And you set it here. So let's see how, what? Yes, mathematics is so awesome. Yeah, and then all will go wrong now. And oh no. I mean there is a trace. Oh yeah, here is a trace here. So let's just get rid of this. Okay. So now what you can see is the proportions have gone wrong. There is a lot yellow and not much of blue or green. So what is happening is the force here is 1, the force here is 1/2, and here it's like 1/4, and only over here it's like 1/10, like 1/10. So if we draw the force like here, so 0, 1, there is 0.5, 0.75, and 0.25, that what we can notice is that only at the very edge here are the green and blue arrows. So only maybe here and here are the green and blue arrows. And like here are the red ones, here are the orange ones, and here are the gray ones. Now why is it happening like this? Well, this is out of proportion, but never mind. It is happening because in fact the values of the arrows aren't scaled like this. They are scaled differently. The red arrow has value 1, the orange has value 0.32, and it goes down exponentially. That means the ratio of the two is always the same. So gray, well, this is green. Well, whatever you get. this is gray and this is green. Awesome notation. And it goes like this. Now why is this? It is to make the red much more powerful than these ones, right? So it is a very fast drop off in value. Now we need to simulate this somehow. Now how do we simulate this? Well, we can see that this is 10 to the power of -2. Do you know about powers? Okay, so if I write 10 to the power of 3, that just means 10 times 10 times 10, right? Yeah, so what is 10 to the power of -3, right? Well, if this is 1000, right, because that we know, and we can go 10 to the power of 2, and that's 100, and that's 10 to the power of 1, and that's 10, right? That's still simple. Well, 10 to the power of 0, well, that's 1, because it always multiplies by 10 when we go up, and it divides by 10 when we go down. So 10 to the -1 is 0.1, and 10 to the -2 to the power of -2 is 0.01, so this is 0.01, right? So it scales like this, and important is every time we go up we multiply by 10. Easy. So this is 10 to the power of -2, and this is 10 10 to the power of minus 1. And I will just write 10 to the power of 0. Now we want to compute these from the force, right? And all that is remaining is what is here in between, when this is in fact 10 to the power of minus 1.5. Well, why? Because, as I said, the fundamental is that here it gets multiplied by constant, like it gets times 10 times 10 times 10, and here a constant is added. It is just plus 1 plus 1 plus 1 plus 1, and here is the same. It's plus 0.5 every time we go up, and here it is times 3.2 every time we go up. So that is just a mathematics, the relationship between like a power and exponentials in general. So these numbers are looking already better, right? Because it is just adding 0.5 every time. But when we want the red field, the distance is small, and when we want the green field, the distance is large. So here we have a small distance, and here we have a large distance. Now that plays into our hand nicely, because this is already a large number and this is already a small number. So here the distance here is already 0 and the distance here is already 1. So we just need to multiply the distance by minus 2 and we get this exponent, and then we need to do 10 to the power of that and we have the force. So that is exactly what is here. It is 10 to the power of this. So 10, this, and then power. And it is the scale distance times minus 2. And that is the force. Right? So does this make sense? Okay, and here it is correct again. So red, yellow, gray, blue, and green. Nice. So now what we need to detect the particles that are in range and destroy them. So that is done here, and we use this that detects the particles around these coordinates. Now this is the range, whether or not to use a square. Now I do use a square because I want to detect the particles that hit this square right here, and you can fine-tune the range. It is about 6, right? And whether or not we want to detect enemy particles. Now since this is an enemy bomb creator, we want to only detect enemy particles, and this will return a list of all the particles in range. So we do this that we saw earlier to get the particles into this. Will get one particle in the list and it will do this many times over, depending how many particles are there, right? So you want to destroy the particle, and 0 means like don't use the sound effect of the destruction. So we don't want it to be causing a lot of noise, so that's why there is 0. And then, or maybe this is the other way around, I don't know, I have the sounds muted, so I wouldn't know. I guess we can take a look, but that doesn't matter that much probably. If the particle explodes in a, yeah, so if it's 0, it will explode. So we don't want it to explode, we just want it to disappear. And then we want to increase our energy, right? That is why we are destroying these particles. Now, the get and set unit energy, we first need to set it up to set the maximum energy of this unit, and that is from here. So you can set how many particles need to be destroyed, because each particle give you one energy. And then we said that we want to show the energy bar and reset the energy to 0 on start. That's pretty simple. So first, when we destroy a particle, we get the energy, add 1 to it, and save it into a variable. And if we detect that we already have enough, right? So this is greater than or equal to this. So the actual energy is at least the needed energy. Then we reset the energy and spawn the bomb. And otherwise we just set the energy to the new energy computed here. Yes. Is it simple enough? Okay. So now how do we spawn the bomb? Well, this is this is a nice thing because we will be creating a unit. The unit will be PRPL core because it's a custom unit. The bomb you can create other units with this, like emitters and the thing that you put on the ground. Like Omnis you can create with this as well. What? Yeah. I mean, you cannot create shapes, but you can create like the stunners, the things that spawn stunners and things like that. I think there's a list somewhere of the things that you can put into this that you can use. I think I may maybe have it opened here, maybe. Probably not though. Yeah, I have it around, so I will add it into the description on the forum when I post this tutorial probably. So yeah, wait, look. No, we want like this. Okay, on the wiki you say. Like here or here? Yeah. Yeah, list of unit types. Oh, here we go. Oh, there's a bit. Oh, you can actually create missiles with this and cannon shots. And I have made a script that does basically the same as the bomb, but with cannon shots instead of particles, and that was fun also. I will do that in another episode perhaps. So yeah, and that is even better for a custom module, but we will get to that another time. So let's return to this. So how do we create a bomb? Well, we first create, well, this is just to save this so I don't have to type it again and again. So we create a new unit, we create a PRPL core new, and we save it, right? And this is where the unit should be spawned. So first the name of the unit, then where it should be spawned, which is the same as the bomb spawner, of course, and then we create it, and this returns the ID of the newly created unit that we save here. So first we add this script to the unit, right? The bomb script. This is the bomb script, and then we set these parameters here, and it's really simple. We just set what unit, what script, because it could have multiple scripts, what parameter, and what that parameter should have value. What value should that parameter have, and then set script var. Right. So the target is where the bomb should go. So you see the bomb going somewhere. Now we just set it to random, so it goes completely random on the map. Now you could probably replace this with something better, like only in a range of the spawner, or maybe check that it doesn't land on land, where it wouldn't be as effective, but well, doesn't matter. We will leave it random for now. Now these three are the parameters for the bomb. This is how much particles the bomb will create. This is how fast the bomb is traveling when it is going from the bomb spawner. And this is if the bomb is enemy or not. Again, you could have friendly bombs as well. So, and these three just get read from these three. This is just copy paste. So even though these two are completely useless for this script, you still need them to be here and able to set them so that you can pass them into this script. So it is good to know that when you create a script, you can set these parameters, and it's really fun. So once we set all this, we don't have to do anything else, because now that this script exists and it has attached this code, it will execute. So let's finish this up. I mean, there's not much left to cover. What we have here is set health. Now this is important to how we set energy. Now we also said that you need to destroy this in order to win, because why not? You can destroy it with lathe. How do you pronounce this? Late? Lathe? Late, right. So we said that you can damage this, and how much damage does the late does. So if this is like 300, it will take a while to destroy. Now I would show you, but there's too many bombs. I mean, we can just do this. Okay, just to get rid of the bombs. Okay, bam, easy. So now let's move this away. Yeah, as soon as the bomb gets created, it is destroyed now. So we can see that it takes damage from the light. Now I will not let it destroy because I don't want to rebuild it again. And what do we have here? Did you watch the last episode? Did you watch the last episode when I made the bomb? Yeah, so nothing much changed. Yeah, this is new. This is how we move to the target position. This is reward, but this is the same, right? This is just copy paste from last time. It is just in a method, so it is like this is like clean and simple, and here is the logic. Yeah, so okay, so this is changed because before there was a oh no, didn't want to press that. So before it didn't work that well because what? Oh yeah, I didn't hit compile here. So now it should. Oh, come on. Oh, there we go. Oh, it just went. No, it was really again it is random. So before, what would happen if there was an enemy ship? Then even if you moved in range, it would not explode because it was looking only for the nearest ship in range, right? So if there was an enemy, it wouldn't explode. Now we want to fix that, and we want to look at all ships in a range. So again, where do we look at yeah? Again? Yeah. So this is a bit different. Yeah, when we have here, it says get particles in range, and you say whether you want enemy or not. And here it will just get all ships in range, and well, you can look here, and yeah, it doesn't say whether or not it is enemy. It says all ships, so it will get all ships. Nice. So we need to go back here. Right. And we save all the ships that we found, and again we go over the list, and now we just ask if it's alright. So this is interesting. Here we ask if the ship is enemy, And here we ask if the bomb spawner is enemy, right? And those two need to be different. If they are the same, then the ship is on the same team as the bomb spawner. So, oh no, this is not a bomb spawner. This is the bomb itself. So if these two are the same, then the bomb is on the same team as the ship, so it will not explode. So these two need to be different. And if you have two Boolean values, like logical values, true or false, and you want to check if they are different, then you use XOR, which means exclusive OR. And it will just check if they are different. And if they are different, you return 1. Now return will immediately stop the execution of the function. So by the way, I should really write this. And what this means that this function doesn't take any parameters. So when you call it, like, you don't need to write something that the function should use, right? No need for that. But the function returns something. It returns a bool whether or not the bomb should explode. Now, before you call this function, the stack is empty, and after you call it, there's this value on the stack depending on how it went down here. So you use if on that value, and if it is 1, then you call this. Yeah. So, right, what do we hear again? If we find a ship on a different team than the bomb is, we push 1 on top of the stack, and return will immediately stop the execution of the function. Like, we don't need to check the rest of the ships in a range. We already know that we want to explode. And if the code gets all the way here, it means that it didn't find any ship, and we return 0. Now we could write this as well, but we don't have to, because the function will return anyway since we hit the definition of another function. So now we do this, right, and we explode. Now what we want also is to move towards the location set here. So by default it is -1, which means we don't go anywhere. The bomb will just stay where it is, and we check for it here. If the target is at least 0, right, this is a Boolean value, and we store it in the travel variable, and this will tell us whether or not we need to travel towards our target. And again, we detect that by if this is -1 or it is 0 or higher, and the bomb spawner will set it to at least 0. It could be 0, it will probably be something positive, right? So if this is true, now this is in cell coordinates. If you remember, then each of these arrows is in one cell, right? You can go, these are cell coordinates, and one arrow, one cell, but one cell equals 4 pixels, and sometimes you need to use pixel coordinates for some reason. And the way to convert cell coordinates into pixel coordinates is to just multiply by 4 and add 2. And why do we add 2? I will just draw really quickly, hopefully. So if these are the cells, and these are the individual pixels, and let's say, no, my mouse was, and we are here in this cell. So this cell maybe has number 4, and the pixel coordinate is here. So if you just multiply by 4, you will only get here, because this is the pixel value 20, right? 16. 4 times 4. But you need to add 2 more to get to the center of the cell, and you really need to get to the center. And that is the pixel value at the center of the cell. That is really what we want. To convert the cell to the center of the cell in pixels. That to convert to pixels we multiply by 2, and to move to the center we add 2. So I hope that makes some sense. And the move we do like this. So we use the pixel coordinates because when we are talking about cell coordinates, the bomb can only move one cell at a time. So if we were moving along the cells, the movement would be very bad. We would move like in a straight line or diagonal, but we could never move at a different angle. Like if you see how I am moving this, it is just jumping like crazy. It is not moving smoothly. And to move smoothly, you can set the pixel coordinate, and that will determine where the unit is drawn at. Like when the image is shown. And we will move according to the pixel coordinates because of this reason. Because we can actually move smoothly using the pixel coordinates. So we save our current location, and then we compute distance to the target. Right? And if the distance is less than 1, then that means we are so close to the destination that we can outright teleport there. And we stop traveling. Right? We say we no longer need to travel, and we move only if we still need to travel. And the reason you do something like this is otherwise, even at the destination, the bomb would like go back and forth and it would never reach perfectly the center. So you say if it is close enough, just teleport there and stop moving. But if it is not close enough, you need to move a little bit closer. Now this crazy equation here. Okay, so let's try to take it one thing at a time. So here we have target minus the current coordinate. So if I delete this, right, let's say here is where we are, the current coordinate, and here is the target. So we want to move like this. Now why do we do target minus the current? Well, imagine if this was at 0, then target is already the direction in which we want to go. But this is probably not at 0. This is like something, let's say current. Oh, it is just called X and Y. And this is target X and target Y, right? Target X, target Y. So this is the X distance, right? You just take this minus this. Right? That is target minus X. And that is the same for Y. And that will get you this vector here. I mean we are doing this X and Y separately, so I don't know. Well, anyway, we divide it by distance. Well, we do this because in reality we want a vector in the same direction as we want to go, but that has length 1. So we are interested in, let's call it X and Y like this. We are interested in this small x and the small y, so that this total distance is y. And like there could be many directions, but we want the same direction as is the direction towards the target. So we take this and we divide it by the distance, and that will give us these two. Now next we multiply it by speed. So if the speed is 2, we get maybe 2 times longer, right? And finally we add it to the current position. So this is the current position, that this will be the new position after this one iteration. So to recap, this is the X distance from the target, and we divide it by distance, so that this is the X distance from the target if the target was just one cell away, let's say. and we multiply it by speed to simulate that the target is speed cells away, actually speed pixels away. Right, so we multiply and then we add it to the current position. So this would move us exactly on the target if the target was speed pixels away, which is what we want. We want to move speed pixels per tick, if you want what ticks is. So that is what we do. And then we set the unit coordinates and the pixel coordinates alike. And remember, one pixel is equal to, no, the other way. One cell coordinate is equal to 4 pixels. And since this is in pixel coordinate, you need to divide by 4 before using this. And by the way, you need to set this first, because setting the cell coordinates also sets the pixel coordinates to the default pixel coordinates for that cell. So this will destroy the pixel coordinates, but this will override them and set them properly. So that is what makes the bomb move smoothly. Now if we swap this, which would be same as just getting rid of this, because these pixel coordinates get overwritten here anyway, but I will just leave that in to show you. Then the bombs would move very weirdly. Oh, this isn't moving. Yeah, they are not moving at all. Because they move such a small amount that they get reset to where they were before. So this is a bit more complicated because of the math and the pixel and cell coordinates and stuff. But if you want to do something relatively simple like moving in straight line, unfortunately it isn't that simple if you look at it. Yeah, thank you. Okay, now you want to see something really crazy as a bonus? Okay, did you see my debugger I made on the forum? So let's call out. Oh, it was that suck the things in and it was spinning also, right? Yeah, I mean I just like when things are spinning, so I always add spinning to stuff. I mean we could make this image spinning if you want. What? Yeah, so let's just try the debugger just for fun. And what are we doing? Like the tutorial one, I think. Is this it? Tutorial one? No, tutorial one. This must be. Oh. So this one maybe? Yeah. I see. I already tried it. So, but by the way, this is a debugger that I made, and you will see what it does shortly. So here we have a bomb, and let's make it. Oh no, we need to. Yeah, I think we need to compile first, and then change it so that it moves somewhere. Let's say 10 times. Oh no, this is all. Okay. Let's not do it like this. Let's go here and change the unit that is spawning to this. And now, no, something. Yeah, whatever. Let's see if this works. Oh, there we go. So now, oh, here. Wait, what is going on? Now this one should go here. Right. So this is the debugger console. Now what is cool is you can actually execute your code step by step. Now as you could see, it takes oh no, I okay, let's do it half speed. Okay, this works. So As you can see the source code here. So this is the code, and you can see the very same code here, and you can execute the code. What is going on? Oh, distance. Yeah. You need to play at 1 speed, because at this speed it doesn't register the clicking. No, just delete and delete. Nice. And you can see the variables. So for example, now we will read the travel variable that has value 1, and you can see that one is pushed on the stack, and the if will consume it and go inside. So let's read this for multiply, right? So you can, or you can do entire line at a time. So 99, you can do step line, and you see it updated immediately. So you read travel, again if goes inside, and now you can either step over, which you would continue here, or you step into, which you actually go inside the function. So you can see current pixel coordinates get the pixel coordinates, which is roughly 4 times. Right? This is the x and y. So we save to y, save to x, and then we continue. Right? We prepare this, compute the distance. Right? 1. We check if this is less than this, which is isn't. So if we'll get the 0 and go here, and you can execute your code like this, and I guess it would help with learning. The only disadvantage is, as you saw, it is quite difficult to set up and make it work. But I will be adding link to the forum post about the debugger into the description, and there is a tutorial on how to make it work. Just yeah. Yeah, did you try it? Yeah, okay. Well, I could do that separately, I guess. Okay, so I guess that's like we could step into this and see that, right, there's just an empty list, right? No ships in range, so it just skips. Okay. We saw it move actually. So, right? It moved a bit. Okay, so anything else you want? Well, what do you mean errors? Like if it doesn't compile like this, right? Or what? No, it doesn't. It will just not work. So yeah, thanks. Yeah, well, I'm glad to hear that. Yeah, I mean, I can imagine it in my head, but if I didn't spend several years at university, I probably couldn't do that. Yeah, okay. Yeah, so you can not only listen but look as well. Okay, so if that's all, thank you for your assistance, and see you on the next tutorial, maybe. Okay. Yeah, see you too. Bye. Okay, so thanks for watching and see you too next time. Bye.